1 squared. And that was what the homework was then also about. Have we marked 1D? Did we finish there? Okay, so now we are looking then now at try now 2. Right, and I said let's draw the pictures just to get it, understand it a little bit more. So the first one is -4, 3, which is then P. The second one is -2, 2, Q, -2, 2, Rain, and I see this is what you were telling me. And then the last one is R, which is 0, 1, which is there. R, 0, 1. So this is more the direction of this straight line. So show that the lengths of PQ, QR, and PR, that's what we need to calculate. So if you work with PQ, you use the coordinates of PQ. And if you calculate QR, that's then the coordinates that you will work with. And the last one is then PR. And actually, PR should then be PQ plus QR. Okay, so what was the length of PQ? You can just give me the answer now. 2.24, 3 significant figures, please. QR, also 2.24. And then PR, 4.47, 48, 47. Okay, you round it here. Okay, but it should then be. We do it with this formula. 16 plus 9 is... No, but you'll have to subtract P and Q. You just worked with P and Q separately, but it must be X and Y. You must use this formula. This is... Okay. And then the last one, show that they lie on a straight line, that these ones lie on a straight line. Now that's always difficult. What do they actually want now here? But the fact that PR is equal to PQ plus QR is what shows that it's a straight line. Another word that they use there is that they are collinear. And it also means that they lie on a straight line. So, but all we're going to say is PR is equal to PQ plus QR. That's what you've shown in there. Then we also had number 3 for homework. A triangle. So this time you have a triangle. X, which is 3, 2. There's your point X. The next one is Y, -3, 0. Y, -3, 0. And then the last one is then 4, -1. 4, -1. So there's Z, 4, -1. Just more or less so that we can see the picture that we have here. This is a triangle this time. Find the lengths of XY, YZ, and XZ. So again, if you have to calculate XY, you work with the coordinates of X and Y. And then YZ and XZ. What is your XY? YZ, 6.32. Okay, 7.1. Okay, 3 significant figures. That's what we go for. 0.7, okay, then it will be 11, 7.11. That's the last one, XZ, 3.16. 3.16, okay. And then they say, show that it is a right angle triangle. Now the question is, when is a triangle a right angle triangle? If you can prove Pythagoras, then it will be a right angle triangle. So we have to show that 6.32 squared plus 3.16 squared, you have to use extra brackets there, is equal to 3.16. That's how you show that something is a right angle triangle. You use Pythagoras. And then they say, find the perimeter correct to 3 significant figures. So I just had to add, even what is the perimeter? Yeah, 16.55, the perimeter. This is then the perimeter. And the last question there is, find the area of X, Y, Z. Now, this is a right angle triangle, so it's half base times height. So which 2 sides are you going to use? This 2. Okay, because this is the hypotenuse. This is not the base and the height. The base and the height must be perpendicular. So the area is then going to be a half of 3.16, and what's the other one? 6.3. Yeah, but what is that value there? 6.32. Okay, and what is your area then, Ben? Now, if I roughly do it there, it will be the same. Right, now, let's look now at try now 4. Try now 4. So it's still coordinate geometry, and we're still just looking for that first one. We're going to do the second formula today. The distance between, okay, let's look at that one, number 1. The distance between P, which is the point K0, and Q, which is the point 0K, is equal to 10. So now they're asking this question another way, isn't it? But because it's the length, the distance, I will still use Pythagoras. So what does that mean? It means 0 minus K squared plus K minus 0 squared is equal to 10. So it's just another way of asking the same question. Okay? And what will it now be? Yeah, so it will be 1K squared plus another one. So I can say that 2K squared is equal to 10. Yeah, no, but if you square it, it becomes a positive. So K squared is then equal to 5, which makes K equal to the square root of 5, which is 2 point something. 2.24. 2.24. So that's the value of K. So it's another way of asking it. Yeah, I'm actually showing you this one. Right, question 2. So the distance, so you're actually going to do the same thing to say that this is 11 minus 9p. So on this side, I will have 1 minus p minus 1, which is then negative p squared. And then the second one is then plus 1 minus 2p squared. So I simplified that first one. 1 minus 1 is 0, so it falls away. So then you have in the root p squared. Now remember, this is 1 minus 2p times 1 minus 2p. Don't be lazy here because you're going to miss the middle term. So it is then 1 minus 4p plus 4p squared, which is equal to the square root of 11 minus 9p. Now in a case like this, we can eliminate the roots here, so this can fall away because it's on both sides. You square it or you get rid of it. So now here I will add my like terms and I will have 5p squared. So this is then 5p squared, negative 4p plus 9 will then be plus 5p, and plus 1. What? Okay, and I bring it over, then it is minus 10 is equal to 0. Okay, and then I can divide it by 5, so it is then p squared plus p minus 5, no, minus 2, which is equal to 0. Then we can factorize here p, 2, and 1. Signs differ, the biggest combination is positive, and that one is negative. So it means p is equal to negative 2, or p is equal to 1. Okay, and let's look at the last question, number 3 there. They also asked it in a very different way here. R is the point 47, S is the point negative 3, 2. Maxine, can we continue? Okay, and now they want the third point T. That's what they want. But the information that they gave us is that RT is equal to ST. So the hint there at the bottom is let T be K0. So they say T is K0. So now RT means I'm going to work with this one and this one. So it will then be k minus 4 squared plus 0 minus 7 squared is equal to, and then S and T is then the square root of k minus negative 3 squared plus 0 minus 2 squared. That's what you need to calculate now there, because the two sides are equal, okay? So this is again going to give us k squared minus 8k plus 16 plus 49. And this one is then k plus 3 squared, which makes it k squared plus 6k plus 9 plus 4. Okay. Yeah, Nendrik, it's this one. K minus 4 times k minus 4. So it's that inner outer. No, 9. Negative 4k is 8. 4 times 4 is 16. That's where the 16 is. That's okay, so this time if I bring this one over, the k's will fall away. So plus 6 minus 8 is minus 14k is equal to, and what is 16 plus 49 minus 9 plus 4? 16 plus 49 and then minus 13. 52. And what is then the value of k? 3.71. So this is asking it a little bit more difficult, not just straightforward the length. Okay, so grade 11s in your book, let's take now the next one for today, the midpoint formula. The midpoint formula. And the midpoint is a coordinate that you're going to calculate, so that's, no, plus x2 over 2, it's a coordinate, so that's why I have the comma there, and then y2 plus y1 divided by 2. Because I need to find the midpoint. I need to find the midpoint. Okay, so that you've got the formula then there, and we're now going to do now, try now 5. Calculate the coordinates of the midpoint between the following points. So try now 5. Let's do the first one. I'll do this one together with you. 1, 4 and 8, 6. So the midpoint is then 9 over 2 and 10 over 2, which is 4.5 and 5. There's the midpoint. Can you see? So there's then the first one, and this is very easy. Can you see? I just need to know my formula, then I can do it. I want you to do, try now 5 and 6 now. So let's quickly find then the midpoints. This is now try now 5. And number, what was number A's answer?
4.5 and 5.
Yeah, so we added 4.5 and 5. That we've learned was the one about the length, and it looked like this: x2 minus x1 squared plus y2 minus y1 squared. And I think you can see, if you write it out a few times, then you know what's going on. The second one that we did yesterday was finding that midpoint. And the midpoint is a coordinate that you want to find over 2, so that's why there's a comma, and then 1 plus y2 over 2, and that is the midpoint. Just applying the formula. And then the third one we're going to get to today. But let's just quickly mark now, try now 6. We marked number 5. Is that correct? So we're looking now at 6. Try now 6. So you've got those points there. Or have we? No, we didn't do this one. Negative 1, 2, that is J. Negative 1, 2. The next one is K, which is 5, 2. So it should lie on the same line. 5, 2. And then 2, 5. So 2, 5 lies here. 2, 5. So there are your 3 points, J, K, and L. Now what you have to prove is that this is an isosceles triangle. So the question is, when will it be isosceles? It will be isosceles if you have 2 equal sides. So it means you have to get the length of those 2 sides. Actually, you will have to get the length of all of them. But again, because I've drawn the picture, I can immediately see that this is the isosceles triangle because these 2 are lying on the same line. It makes it easier. You keep on talking. So is it JL and LK? That's the 2 sides, JL and LK. And what was then the length that you got for this one, Marley, for these 2? JL and LK, 4.24. 4.24. So then you can say they are isosceles. The 2 are isosceles. Make that statement there. The next one is now find the area of the triangle. Now to get this area, again the sketch helps you a lot. We can see that there's the perpendicular height. So it is half base height. So I actually need this length as well, the base, isn't it? Because you don't have the base now, JK. What was JK? 6. So we need that one as well. So area is half base height. So it's half of the base of 6. And oh, you got the midpoint coordinates, and then we can calculate that length here. So the midpoint coordinate here is 2, 2, 2. Yeah, 2, 2. And then we can get the length between these 2 here, which is what? So that's the height, and the area is then 9 square centimeters. Or square units if you don't have centimeters like here. Right, the second question, question 2. Find the perimeter and area of the triangle RST whose vertices are. Again, I hope you can see that the drawing is helping you every time to see what you actually should do. This is then R. S is the point 8, negative 2. Also on the same line is 8, negative 2. And then the last one is T, which is 2, 6. So there's T, 2, 6. So here is your triangle then there. Okay. And now they say, find the perimeter and the area. Now, the perimeter means I need all 3 sides, and the area will have to do the same that we did just now. So what is the length of your RS? 12. What is the length of your ST? 9. RT? This one is 9. Is it also 10? So how did you get 9? I used Pythagoras. I used Pythagoras to get that. No, that won't work because it's not to scale, so it will definitely not work. You'll have to calculate it. And so the perimeter is then 32. The perimeter is 32. We call it units because it's not centimeters or whatever, then we work with units. And now again, we can do the same thing to get the area, that we will have this perpendicular height here. Yeah. Okay, so what is the midpoint's coordinates here? 2, negative 2, that's right. And then we need to get the height, we need to calculate this length here of TM, let's call it M, the midpoint. So then you also have to calculate TM. So area is then half base height. And the length of the base was 12, and we say the height is 8. So the answer is 48 square units. Look here, this is what we use, unit square. In a case like this, that's what you will be writing then there. Okay, so today we come now to the third formula that we need to know, and this is the gradient. And we know that the gradient is M. M is your gradient, and the gradient plays an extremely important role. We're going to do a lot, eventually calculus is all about the gradient, so that's what we're going to do. So the gradient formula is delta y over delta x. Now we're going to say y2 minus y1 over x2 minus x1. It's still delta y over delta x. It's just to get that length, that this is the formula that we're going to use. Write it in your book and highlight it so that you can see it. Okay, find the gradient of the line joining the points. So I'm going to try now 7 orally, so you don't need to write it down. Let's just work on the paper. So we have the coordinates A, which is the point 0, 0, and we have B, which is 2, negative 2, 1. So it's still y2 minus y1, so it's negative 2 minus 0 over 1 minus 0, which is then negative 2 over 1, and that's negative 2. So that is the gradient. So it is 1 minus 0 over negative 2 minus 0, and that's then negative a half. So the slope will be negative. The slope will be negative there. Okay, number 2, plot the points on the coordinate plane, and then what can you say about the line segments? Oh, then we have the second one, number C and D. So C is now negative 4, 0, and the second one is then negative 2, negative 1. So this will be negative 1 minus 0 over negative 2. Be careful here with the signs, because otherwise yours is going to be wrong. So it's negative 1, and then negative 2 plus 4, which is positive 2. Yeah, but positive or negative? Also negative for half. Okay, now I'm not going to draw this one now, but if my gradients are the same, it's going to be parallel. So these two lines, AB, will be parallel to CD. If the gradients are equal, the lines are parallel. Okay, so let's try now 8. Find the gradient of the lines, but you don't need to plot them. We are just going to make a deduction from that. We're not going to draw all of them there. So I want you now to do 8 and 9. Grade 11s. So in the first place, we've looked now at the length formula. We're still busy now with coordinate geometry. And this one was then x2 minus x1 squared plus y2 minus y1 squared. The second one was the midpoint formula. Make sure that you know them now, which is then x1 plus x2 over 2. This is a point that you get, so that's why there's a comma in the middle. And then the third one that we're looking at now is the gradient. Now people, eventually this gradient is going to become very important in your grade 12 higher level here. So we're going to do a lot on this gradient, but eventually it comes back to this one, delta y over delta x. And now when we have the coordinates, this is what we're going to do. Remember, delta y over delta x, don't swap them. because we're later on going to do vectors, and then they're the other way around. So make sure that you remember this. Okay, so this was then exercise. We did try now 7 in the class and 8. So we're now at try now 9. Have we finished marking 8? That's where we should start. Okay. So the first one then here is the now try now 8. And it says plot the points on the coordinate plane, and what can you say about them? But I told you it's not necessary to draw them. We can deduct it from the gradient that we get then there. So the first one, EF, is then going to be 0 minus negative 2 over 4 minus negative 4. Look at my signs. If you go wrong there, if you don't substitute in brackets, you're definitely going to get wrong answers. So this one is then a quarter. This is then of the line EF. And the next one is the line GH. And this one will then be negative 4 minus 4 over 0 minus negative 2. So this one is negative 4. Now, when you draw it, and what I want you to see is that these two lines are going to be perpendicular. So that is what we have to realize here. EF is then perpendicular to GH. Why can I, perpendicular to GH. How can I say that? The rule is M1 times M2 is equal to negative 1. If that is true, the lines will be perpendicular. Now, can you see, if you multiply a quarter with negative 4, then I get that negative 1. In short, we say it's a change of sign reciprocal. It's the change of sign reciprocal. Okay, now I'm going to ask you a few. Let's say the gradient is 5. What will be the perpendicular one? Change of sign reciprocal. If the one is 5, then the other one is negative 1 over 5. Change of sign reciprocal. So if the first gradient is a third, what will be the perpendicular one? Negative 3. If the first one is a half, negative 2. If the first one is a 6, negative 6. If the first one is 2/3, what will be the perpendicular one? Change of sign reciprocal. That's how you get that perpendicular line. We're going to do a lot on this. So make sure that you understand. Right, now the next question is now try now 9. Try now 9. And I assume you struggled perhaps a little bit here because they are much more difficult here, the next one. Right, if the gradient of the line joining the 2 points is equal to 2/3, find K. So all that we do now is to apply the gradient rule. This is what you're going to do. So you've got the point P, which is the point 2, 3, and you've have the point Q, which is K7. So in this case, you don't need to find the gradient. You have the gradient, but you must find K. So I'm going to use exactly that formula of y2 minus y1 over x2 minus x1 to get that answer there. So it will be 7 minus 3 over k minus 2. Can you see this is my rule that I apply, and they tell me that the gradient is 2/3. The gradient is 2/3. So that's how you will start to find this one. So obviously this is now LCM or cross multiplication. You can also use that. 7 minus 3 is 4, and 4 times 3 is 12. And then if I multiply the 2 here, then I have 2k minus 4. You could have used LCM method as well, but we can also use that cross multiplication here. So 2k is equal to 16, which makes k equal to 8. K is equal to 8. Who got that answer? K is equal to 8. So I apply my gradient rule. Number 2. Number 2, the gradient of the line passing through A. Okay, so A is 3 K8. In this case, we can't draw them because you won't be able to see what's going on. And B is then the point K negative 3. The gradient of this line is 3, find the value of K. So we're going to do exactly the same. I use my gradient formula, which will then be negative 3 minus 8 over K minus 3K, which is equal to 3. Can you see? Okay, so this one will then be negative 11, negative 2K is equal to 3. Okay, so then negative 11 is equal to negative 6K, and this makes K then equal to 1 and 5 over 6. K is then 1 over 5 over 6. Who had it correct? It's just your gradient formula that you ask, but this is what you can expect now, more the kind of questions. And then especially next year in higher level, then we'll do more and more of this. Question 3. The points A, yes? And B is then 3 negative 2, and C is 8K. Okay. The points lie on a straight line, find the value of K. Now, what happens if they lie on a straight line? A, B, and C lie on a straight line, find the value of K. Yeah, that's what we've done with the other question that we said, by using Pythagoras, we can show that the lines are on the same line. No, not Pythagoras, the length formula, calculating the lengths of the different ones. But what we can also say is that they the gradients will then be the same. If they lie on the same line, then their gradients must be the same. Can just picture it a little bit. If they lie on the same line, then that means their gradients must be the same. So what I think here is if we say negative 2 minus 3 over 3 minus 2 is equal to, so this line's gradient AB is equal to BC. And BC is then K minus 2 over 8 minus 3. Okay, so look at the signs. One should be very careful here. So this is 1 over 1, isn't it? Negative 2 minus 3 is 1 over 1. And on this side, it will be K plus 2 over 5. Now, is it 8 plus 3 or minus 3? Now 8 minus 3. Yeah, so that's right. So 5 is equal to K plus 2, LCM, and K is then equal to 3. The value of K. So when will they lie on the same line? If the gradients are the same, then they can lie on that same line. So it's still that gradient that we are looking at then here. Right, the next one is number 4. The coordinates of D, E, and F, so that means D is going to be 6, negative 11. E is going to be P, negative 9. And F is then equal to 2P minus 3. I'm showing you this because we have learners who struggle with that. Look at that word respectively. That's why I can say the first one is D, the second one is E, and the third one is F. That's the word respectively that you get there. And now they say if the gradient of DE is equal to the gradient of EF, so it's exactly like the previous one. We're going to prove that the gradients are equal. So negative 9 minus negative 11 over P minus 6 is equal to negative 3 minus negative 9 over 2P minus P. The gradients are equal. So I work with the gradient formula. Right, Jan? What did you get the gradient here? Negative 9 minus 11. 2 over P minus 6 is equal to negative 3 plus 9 is 6 over 2P, and 2P minus P is actually P. So I can just write it down there. So now I'll have to do the LCM, or as I say, you can use cross multiplication It is the LCM, but if we have this is equal to this, then we can use that method of cross multiplication. So 2p is equal to, if I multiply here, 6p minus 36. So negative 4p is equal to negative 36, which makes p equal to 9. P is then equal to 9. Nice questions. The last one is number 5. A is then negative 6, 7, and B is 5, negative 2. Now they say they intersect the y-axis at the point C. Find the line segment joining those 2 points, intersect the y-axis at the point C. Oh, I wonder who could do this one. So the gradient here is then going to be negative 2 minus 7 over 5 minus negative 6. Okay, so Chris, the gradient? Negative 9 over 11. So, and then they say, and it intersects the y-axis at the point C. Find the coordinates of C. So now it is, the equation will now be y is equal to negative 9 over 11x plus C. We need to find C. How are you going to get those? What did you do? Yeah, you substitute. You substitute. So either A or B, doesn't matter which one. It must be the same. You get the same answer there. So we're going to substitute. And this is basically also the method that we're going to apply now to get our equations. That's what we do from here. So 7 is equal to negative 9 over 11 times negative 6 plus C. Not a very nice question. And what did you get? 23 over 11. Okay, so what is the coordinates? If you cut the y-axis, x is 0. So that will then be the set of coordinates for the point C. For the point C. Okay, now from here, you can draw a line underneath your homework, and now you can say, just right on top, find the equation. Find the equation. So what we're doing now is to find the equation of a straight line graph. And what is it that we want? That equation of the straight line graph. Y is equal to mx plus c. This is what we want. We want y is equal to mx plus c. So if you read that question, find the equation, write it down. Because the moment when you see that, at least you know what you're heading at. So what do I need to find? I need to find m, and I need to find c. That's the two things that I need to find now. How do I get m? What is m? M is the gradient, so I'm going to get it with a gradient formula. And how am I going to get c? Substitute. We're going to use substitution. Okay, so just write here gradient with a gradient formula, and c you find with substitution. Substitution. Yeah, so if you have 2 points, you can find the equation of the line. You can find the equation of the line, and that's what we're going to do now. So we're looking now at try now 10, and I'm going to do number 10 on the board for you, showing you examples, and then we'll go to the book. Okay, you should be glad, because otherwise you have to do everything. Okay. So it says, find the equation of the straight line. So what do I want? Y is equal to mx plus c. That's what I want to do. They give you the gradient this time, so you don't need to calculate it, and it goes through the origin. Now that one will be y is equal to negative 3 over 4x, and if it goes to the origin, you don't need to write this down, we just do it orally. What will be c then? If I go through the origin, c is 0, so I don't need to write it down. You're right, c is 0. It goes through the origin. Right, the second one there, you see the gradient is negative 2 for negative 1. Okay, because otherwise I don't understand why I should change it. So that one is 4 and this one is negative 1. So then this is the negative 8 plus 8, which will make it 7. So the equation is negative 2x plus 7. Okay, now let's do right number 2. Find the equation of each of the straight lines below. The gradient and the coordinates are there. So this is easy because we don't need to calculate the gradient. It's given to you plus C. Then 1, if you substitute 1 and 1 in there, C is going to be -2. So the equation is y is equal to 3x minus 2. So that is the method that we use now. Now I want you now in your books to start with try now 11. Try now 11. Remember, everything is now about y is equal to mx plus c. Okay, so this is try now 11, number 1. You want the equation which is parallel to this one. So because it is parallel, it will have the same gradient. So that's, Jano, what we start with the same gradient. And then you substitute the coordinates in because this line passes through a new point there. And then we get that C is -1. So this position here will be -1, but this is your answer then there. That is then your answer there. This gives you +5, and 4 minus 5 is -1. Right, the next one is number 2 now. Determine the equation parallel to 2y plus 4x is equal to 7, and it passes through the point C, which is 2, -8. So again, you'll have this situation that you actually have two lines which are parallel, -2, +8. Okay, but now I don't, so what do I want? I want y is equal to mx plus c. We always go back to that standard form. You don't have it, so you don't have a gradient now for the first one. So with algebra, I changed this one now first. So 2y is equal to -4x plus 7. So y is equal to -2x plus 3.5. Because they are parallel now, the gradient will be the same. So it means, what is my parallel line's gradient now? -2, -2. So y is equal to -2x plus c. And to find c, we always substitute. So that will then be 8 is equal to -2 times -2 plus c. So what is your value for c? So look here again, as +4, and if you take it over, it's 4. So the equation is y is equal to -2x plus 4. Right, we continue now with try now 12, and it's going to be the same kind of questions that we're going to get there. But this time they are perpendicular. So I'm going to do the first one again together with you. So try now 12. Pay attention. This is usually very difficult stuff for the learners. Find the equation. What must I do? Y is equal to mx plus c. That's what I need to find. And now they say the straight line perpendicular to y is equal to 4x minus 5, and it passes through the point -2, 4. Okay, now what did we say? So the equation is now y is equal to 4x minus 5. When will they be perpendicular? So first we need to find this one's gradient, and this one's gradient here is 4/1. So the perpendicular gradient is a change of sign reciprocal, Ben, which will be what? The perpendicular gradient is a change of sign reciprocal, -1/4. Because if I do this, I get that -1. So this is the perpendicular gradient there that I'm working with there. So y is equal to -1/4x plus c. It doesn't pass through that point now. It has a new point. Look here, the lines look like this. And the other one is perpendicular now to this one. That's what we're doing now here. And it passes through the point -2, 4. So if I substitute that now in, 4 is equal to -1/4 times -2 plus c. So what is your value of c? This gives you a half, +1/2, isn't it? Yeah, the perpendicular one. So +1/2 minus half, what do you say c? 3.5. 3.5. 3.5, you can use it as an improper fraction or like this. And then my equation is y is equal to negative a quarter x plus 3.5. That's your equation. That's your equation that you have there. Okay, now I want you to continue with number 2 and then also try now 13. Try now 13. So let's quickly do that. Every time to draw the picture just to get the idea of what we are talking about. And the first one that we're looking at now is the length. So the formula that we deal with here is x2 minus x1 squared. That is your coordinates. y2 minus y1 squared. That is what we will be using. So if you look now on your worksheet, there's the length formula. I've pasted it there for you. Calculate the distance between the following points. Give your answer correct to 3 significant figures. Now we're going to draw it and then we're going to do the calculation. So in your workbooks now, try now 1. No, page the paper. So if you plot it now there, the first point there is negative 2, 4. And the second one is 5, negative 3. So we just draw them. Please don't draw them precisely and put all the numbers in. It's a waste of time. Just use the applicable ones so that we get the idea. And this is then the line length that we need to calculate. That is what you want to calculate now there. This always forms a right angle triangle. And this is why we can use Pythagoras then here to calculate that length. So it's actually the hypotenuse that you are calculating there. Which one is now this one or this one? Actually, it doesn't matter. That the signs will cancel out, so it won't matter. But you can start with any one. Just to make it easier, we'll take this one as the first one, and this one is the second one. So to do the calculation now, you're going to say negative 2 minus 5 squared plus 4. Now be careful with the signs here. Minus 3 squared, and then you can calculate it. Okay, what is the answer? You need to use your calculator now to get those values. So 9.89, and that is then the length of that one. So we just use the formula and subtract the 2. Yeah, this is what I used. So this is x1, y1, and this is x2, y2. And I just used my formula now there. 9.899. So the rounding is not correct. 9.899, which rounds off. Look at this symbol that we're going to use this symbol for the rounding, and in trigonometry and as well as geometry, which we're also going to do just now, we're going to use it a lot. But I would advise you to listen here, first write that one down, because you're going to use it in a B or C question, and if you haven't rounded it off correctly, and you work with premature rounding like a premature baby, then you're going to have to recalculate it every time. So get used to first writing it like this and then round it off, and that will then be to 3 significant figures. So if you look here, minus 2 minus 5 is negative 7 squared. It's vitally important. It's vitally important that the square will be outside the bracket. If you put that square inside the bracket, you're going to get the wrong answer. And the same here. This is then 7 squared plus 7 squared, so 49 plus 49, the square root of that. So I get the same answer there. But that square must be outside the brackets, otherwise you're going to struggle. Then put extra brackets if you still struggle. Okay, right, now the next one is number B. This time it looks, draw the picture, it's 4, 7. And the second one is negative 5, 9. So there you are, negative 5, 9. And this is the line then that we are calculating. There's Pythagoras. So the purpose is now that you can see it. So use your formula. The only way to learn it is now to use that formula every time. Right, B, C, and D. You are not working. I don't see any sketch up to now. Okay, so let's see. This one is the negative 5 minus 4 squared plus 9 minus 7 squared. Yeah, just a second. I just want to double check. 9.22. Okay, so this one's answer, it rounds then off to 9.22. Okay, C and D. I want you now to try C and D. Right, so the next one is now number C. Still working with the length. Draw the picture there. So it is negative 2, 3, which is almost there. Negative 2, 3. And the second one is then 7, negative 2. So there's your point, 7, negative 2. This is the line that you want to calculate. So can you see, there's your Pythagoras coming up. But I'm just going to use my formula now. So I would like you, so this one time it will be negative 2 minus 7 squared plus 3 minus 2. Look at those signs there. That's very important. And let's quickly get that one. I would like, press your calculator. So it doesn't matter. It doesn't matter which one you choose first. You must just not swap it. So if this is x1, then that one is y1. And this is x2 and y2. You can start here, you'll get exactly the same answer. You must just not swap the two. Because we get that. Do you have a problem? Okay, what is the answer? 10.3, do you agree? Do you get that? And I would like you to do the last one then there. So that one is going to be negative 11 minus negative plus, and then the second one is then 1 minus 8 squared. What do we get? Again, please try so that we can see if you get the same answer here. Right, so I want you to draw the pictures. I will draw the pictures to let you understand. You'll see at the next one, they say now find the lengths PQ, QR, and PR. So it's a triangle that you get there. And then you must show that they lie on a straight line, P, Q, and R. And then the next one is those vertices. So I want you now to do 2 and 3.
Hi everyone, we are from the Giraffe Conservation Foundation. Our team protects and supports the safety of giraffe in 15 African countries. Together, we are going to explore and share a lot of interesting environmental facts with you. My name is Naomi.
I'm Audi.
And this is Martha. Welcome to episode 4 of Environmental Learning with the Giraffe Conservation Foundation. Today we are going to learn about a tall, long-legged, long-necked, stretchy animal, and it's Africa's giraffe. How much do you know about giraffe? Well, there's lots of interesting facts about them, and today we are going to expand your knowledge.
When we think about giraffe, we think that there is only one species, like the springbok. But did you actually know that there are 4 species of giraffe? And these 4 species are the Maasai giraffe, the reticulated giraffe, the northern and the southern giraffe.
They live in 21 countries throughout sub-Saharan Africa, from Namibia and South Africa in the south to Uganda and Kenya in East Africa, across Central African countries like Chad to Niger in West Africa. Here in Namibia and South Africa, we have the southern giraffe and both its subspecies, the Angolan giraffe and the South African giraffe.
Every giraffe is different. No two giraffes have the same patterns, just like no two human beings have the same fingerprints. And this is how we tell them apart.
But how do we know which one is a female and which one is a male giraffe? Giraffe horns are called ossicones, and to tell them apart, you need to look at their ossicones. Male giraffe ossicones are thick and they often have no hair on top. Female giraffe ossicones are thin with long fluffy hair on top.
Here are some amazing giraffe facts. An adult giraffe's neck is about 2 meters tall, and that's the same height as a classroom door.
An adult giraffe's tongue is about 50 centimeters long. This is longer than your school ruler.
Giraffe can really run fast. They can run up to 50 kilometers per hour. And this is as fast as a horse galloping at full speed.
Like humans and most mammals, giraffes also have 7 bones in their necks. Their necks are just a little bit longer.
Giraffes are the tallest land mammals in the world. A newborn baby giraffe stands at about 1.8 meters tall, and this is taller than most humans.
Giraffes are browsers, which means they eat leaves, flowers and fruits from the trees and bushes. Remember the camel thorn trees? Camel thorns are their favorite trees.
Giraffes already no longer exist in at least 7 African countries. There are only 111,000 giraffes in the whole of Africa. Compared to elephants, that is 1 giraffe for every 4 elephants in Africa.
Almost 50% of all giraffes lives in Southern Africa. The good news is that their numbers continue to increase, especially here in Namibia, but it's because of the many different people working together to protect them.
However, the not so good news is that in some parts of Africa, giraffes are in a serious trouble. The Kordofan and the Nubian giraffe, which are both subspecies of the northern giraffe, are critically endangered. The reticulated and the Maasai giraffe are both endangered. Some of these populations of giraffe are rarer than the mountain gorillas and the black rhinos.
Giraffe needs urgent help, and this is what we do. The Giraffe Conservation Foundation works with and supports other African countries to protect this wonderful animal.
Throughout Africa, giraffes face many different kinds of threats. The main problem for giraffes is the human population growth. There are more and more people living in Africa, and all these people need more space to live and to grow food. Because of this, the food available for giraffes and other wild animals gets less and less, and their space becomes smaller and smaller. In many other areas where giraffes also live, their habitats are being divided up by new developments such as roads and railway lines.
The other threat that giraffes face is illegal hunting or poaching. In certain areas, people hunt giraffe illegally for their meat or other body parts such as their tail or their skin.
The good news is that we are working passionately to support and protect giraffes so that they can live safely and happily wherever they are. As part of this support, we have moved 130 giraffes in Africa to safer homes.
World Giraffe Day is celebrated on the 21st of June, which is the longest day or night of the year, wherever you are in the world, for the tallest animal.
We use the World Giraffe Day to raise awareness about giraffes and to celebrate them all over the world. You could celebrate the next World Giraffe Day with us, so be sure to tell your family and friends about the World Giraffe Day.
You can also follow us on all GCF social media platforms so you can stay in touch and also find out how you can celebrate World Giraffe Day with us. Perhaps you can create an event with your friends or at your school.
We have come to the end of our time together today. But before we say goodbye, we would like to leave you with an action that you can do by yourself, with your family, or with your friends.